Okay, good morning. We're going to start getting into the trig ratios part of this whole chapter today. So this is kind of where we're going to be for quite a while. And this is really what kind of trig is all about. Now, I'm not going to dive into where this all comes from or how it's going to be used in some of your future math classes. I'm going to save that for you guys to learn from, I suppose, Mr. Stitt eventually when you get to him, just because it's not as useful for us here in geometry to know where it comes from, especially given the circumstances with us being at home. I don't want to confuse you guys any more than you might already be getting confused when I start showing you some of these trig ratios and everything. So we're going to keep it simple. We're going to keep it useful for us in this class when we're dealing with triangles. But just know that as you move forward, you're going to start seeing that the trig stuff, while it sounds like it's all about triangles, it's kind of like circles in disguise. And you'll see where that comes from in some of your later classes. So what are the trig ratios? Well, there are 6 of them. 3 of them really, but even then kind of only 2, because the third one ends up being a ratio of the other 2, and then those last 3 that would make the 6 are just kind of the inverses of the other ones. The main ones that we're going to have, we're only going to look at the primary 3 here. We've got sine, cosine, and tangent. These are our trig functions: sine, cosine, and tangent. And each one of them, we apply that function to a given angle, and it gives us some response back. It gives us some number back. In the case for us today, it's going to be a ratio that we're going to get back. I'm not really worried about the number that it gives. I'm worried about the ratio that it's going to give you back. And this is why I've had you practicing with these triangles, your 45, 45, 90, and your 30, 60, 90 triangles. And it's also why I've had you practicing with your opposite, adjacent, and hypotenuse for any given angle. So that, like, if I looked at this 45-degree angle up here, we'll call that angle B. I have it listed. If I looked at angle B, I could see that the side here that I'm pointing at, that is my opposite, this is my adjacent, and this is my hypotenuse. It's very crucial that we know that for whatever angle we're looking at to figure out these trig ratios. So what are they? Well, the easiest way, or the most useful way to describe them here, is basically what their trig ratios actually are. For sine of a given angle, we have opposite over hypotenuse. For cosine of a given angle, we have adjacent over hypotenuse. And for tangent, we have opposite over adjacent. These are the ratios that we want to be thinking about anytime you hear these words. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. These words come from, I believe, ancient Greek. When they would have a bow with a bowstring, it would be something called sinew, S-I-N-E-W. That's where this comes from. That's what the string was. There's a nice YouTube video on it that I was going to show you guys. Just Google where those things come from. I'm sure you'll come up with it. But where they come from doesn't particularly matter. Just know this is what they're called. These are the ratios that they represent. So there's a little phrase that you can use to help you remember these ratios. That sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. That phrase is this: so, ka, toa. So katoa, sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Toa, tangent, opposite over adjacent. So, ka, toa. I highly recommend that you remember that. I still remember it to this day. It's what I've used all this time to reassure myself that I know the right ratio is the one that I'm using. And we abbreviate each one of these little things here as well. Sine, we abbreviate to just sin, S-I-N. Cosine, we abbreviate to just cos, C-O-S. But it's still cosine. And tangent, we abbreviate to just tan. So we just use the first three letters of each one. Now, let's take a look at what this might look like in terms of a problem. And we're going to use these special triangles here real quick, because these are the ones that, as you do these problems and you see this stuff come up so much, these particular triangles, they tend to just lend themselves straight to memory so that you know exactly what, for instance, the sine of 45 is, or the cosine of 60 is. So let's take a look at that real quick, and then we'll do a couple examples from the assignment that I gave you. And we'll take them just a couple steps further, as a matter of fact, to really get an idea of what's going on. So I'm going to put my little toa here at the top, just as a reminder. And now, let's say I take this 45, 45, 90 triangle. Let's say that I wanted to know what is the sine of angle A, the sine of A. And this is how we're going to start writing these as well. The sine, and then in parentheses, the angle that I'm looking for. Sometimes you might see it also written without the parentheses, but with the space there. If I'm writing them out by hand, I will always put the parentheses around it. So the sine of angle A for this triangle over here. Well, angle A happens to be my 90-degree angle. I'd want to do opposite over hypotenuse in this case, because sine is opposite over hypotenuse. But for a 90-degree angle, do you see that the opposite is my hypotenuse? That's weird, isn't it? We don't actually like to use the 90-degree angle for these things because like, weird things tend to start happening. Okay? We don't like to use the 90-degree angle because weird things start to happen. Now, the thing that's going to be true here is for our 90-degree angles, you're going to start getting answers like 1, -1, 0. Those are going to be the answers that would come up on your calculator if you were to type them in. And as a matter of fact, for this sine here, for 90 degrees, we would get 1. We would get just the x root 2 over x root 2, which it's 1. Now, we're not going to use that though, and I just want to stress the fact that we don't really use the 90-degree angle for these. Better safe than sorry, just memorize what the actual values are for each thing. For instance, cosine of 0 is 1, cosine of 90 is 0, cosine of, it's not, yeah it is. Cosine of 180 is -1, cosine of 270 is, well, 0 again. Don't worry too much about that. Let's do maybe a better example. Let's find the sine of B. Sine B. So the sine of B, I look up here to angle B, and I want to do the opposite over the hypotenuse because I'm dealing with sine, hypotenuse. Sine is opposite over hypotenuse. So I look at angle B and I say, which one's my opposite? Well, my opposite is x. Which one's my hypotenuse? My hypotenuse is x times root 2. And now we just simplify that. X's cancel, giving me 1 over root 2. And then I don't like roots in the denominator. So multiply by root 2 over root 2. And we get square root of 2 over 2. That is what the sine of angle B in this case is equal to. And we know actually in this case what angle B is. Angle B is 45 degrees. So the sine of 45 degrees is square root of 2 over 2. Always, for every triangle. No matter which triangle I do, I could have a 6, and a 6 root 2 here. The sine of 45 degrees is always square root of 2 over 2. No matter what. As a matter of fact, the cosine would work the same way because my adjacent side to B would also be x. Let's move down to my 30, 60, 90 triangle. And let's do the cosine of angle C. Let's see what I get for that. Cosine says that I want adjacent over hypotenuse. Adjacent over hypotenuse. Now I look at the triangle that I'm using for this, which is this guy. That's what I had said. The adjacent side to angle C. So I want to base everything off this. The adjacent side to angle C is x. The hypotenuse relative to angle C is always just going to be 2x because hypotenuse is opposite the 90 degrees. So x over 2x. Simplify, and I get 1/2. So the cosine of C is 1/2. And in this case, we also know what C was. That's 60 degrees. The cosine of 60 degrees is equal to 1/2. Same triangle, let's this time do the sine of angle C. When I change this to sine, now I'm using opposite over hypotenuse. So I don't want this adjacent here. Now I want opposite. The opposite side to angle C was x times square root of 3. So there's what I've got. Now we simplify once again. The x's are going to cancel, and I get square root of 3 over 2. So the sine of C is square root of 3 over 2, which means the sine of 60 is square root of 3 over 2. The sine of 45 was square root of 2 over 2. The sine of 60 is square root of 3 over 2. And let's do one tangent example here as well. For the same triangle, let's do the tangent of angle B. Again, I'm going to stray away from that 90 degrees. I don't really want to think about the 90 degrees. This stuff, we have to apply it to a 90-degree triangle, or a right triangle rather, for now. Eventually, we're going to figure out how we can use this stuff for a not right triangle. But for now, we're applying it always to a right triangle, and we want to choose one of the other two angles, not the 90-degree one. So the tangent of B, tangent is opposite over adjacent, opposite over adjacent. Opposite the angle B, we've got an x. Adjacent to angle B, we have x times square root of 3. Simplifies to 1 over square root of 3. Again, I don't like my radicals in the denominator. So multiply by root 3 over root 3, and I get square root of 3 over 3. That is the tangent of B in this particular example, which is then the tangent of 30 degrees, is square root of 3 over 3. Now, I'm going to put a triangle up here from the work that I gave you, and we're going to figure out what some of these trig ratios are from each of the angles for maybe 2 problems, I think. So we'll start off with the first one, just number 1 here. I can get rid of these special triangles now. I'm not going to be using these ones. I'm going to be using the examples that the worksheet gives. The triangle given is 21, 28, 35. 21, 28, 35. Square root goes there. And they have these angles labeled X, Y, and Z. X, Y, Z. The first thing that the worksheet wanted was it wanted to know what is the tangent of Z. So tan Z. Well, tangent is opposite over adjacent. The angle I'm looking at is angle Z. So down here at angle Z, the opposite for angle Z is 21. The adjacent for angle Z is 28, not 35. Remember, 35 would be the hypotenuse. So 28 is my adjacent. And I could simplify this a little bit. These are both divisible by 7, so I get 3/4. The tangent of z is 3/4. I could also figure out, and this isn't on the worksheet, but just to show you and take this a little bit further here, let's figure out what the cosine of x is. I could certainly figure that out too. So here's x. I'm looking up here, and cosine, according to this, is adjacent over hypotenuse. So adjacent over hypotenuse. What's adjacent to this angle x? The 21. Again, not the 35. The 35 is the hypotenuse. Speaking of, I want the hypotenuse here, so 35. 21/35. Again, both of these divisible by 7. So divide by 7, and I've got 3/5. The cosine of angle x is 3/5 for this example. And then let's do the sine of angle z as well. Sine of angle z. Sine is opposite over hypotenuse. The angle I'm looking at is angle z, so I'm looking down here. Opposite that, we have the 21. The hypotenuse is 35. Wouldn't you know it, we got the same thing. The sine of z is 3/5 in this example. All right, let's do one more, and I'll wrap things up here. Next example was 16, 30, 34. 16, 30, 34. (16, 30, 34) with the labels A, B, and C on each angle. A, B, and C. And the worksheet just wants 1. We're going to do 3. The worksheet wants the cosine of C. I'm also going to want the tangent of A and the sine of C. So let's start off with the one the worksheet wanted, cosine of C. Cosine means I want adjacent over hypotenuse. The angle I'm looking at is angle C. The adjacent is 16. The hypotenuse is 34. Looks like 2 goes into both of those. So 8/17. Cosine of C is 8/17. For the tangent of A, tangent is opposite over adjacent. I'm looking at angle A this time. Opposite is going to be 16. Adjacent looks like it's going to be 30. So 16/30 is what we have here. Again, looks like only 2 goes into both of those. We've got 8/15 for the tangent of A. And last one, sine of C. Sine is opposite over hypotenuse. And I'm looking at angle C this time. So C opposite 30, hypotenuse 34. So 30/34. For these two, again, looks like just 2. So we've got 15/17. So you're going to just go through 1 through 18 on that worksheet. All you've got to do is figure out the thing that it wants, whether that's the cosine, sine, or tangent of the angle that it tells you to. use these ratios. Keep them in fraction form for me. Just reduce the fraction if you can. And that's it for now. Wednesday, we'll take a look at how we can calculate the sine, cosine, and tangent of some numbers. And then we're going to try to go backwards with this stuff and maybe figure out some other stuff, mix some algebra in with it. So this is just the beginning. Have a good one, guys. Let me know if you have any questions via email or the Zoom meetings. We'll see ya.